Yeah, good. Oh, wow.
There are a lot of different types of two-step equations, so I really can't do them all in one lesson because, you know, 2 steps means it takes you 2 steps to get the answer, but the reality is they all look so different. We're going to break them up into different forms. So the first form is going to look like this: ax plus b equals c. What that means is you'll have a coefficient, then you'll have x, then you'll have another constant number being added or subtracted, and then another constant number on the end. First example, just a simple one. I'm going to make 3x minus 4 equals 8.
Can I?
Well, you tell me, don't give me the answer, tell me what you're going to do first.
Change sign of 4, so you add 8.
Okay, so step 1 says we're going to add or subtract the constant on the variable side. So 4 is a constant, and it's on the variable side, not the coefficient, but the constant, meaning the number being added or subtracted. Like he said, we're going to do the reverse of that, so we're going to add that to both sides. That way the 4's will cancel. Yeah.
Not to go off topic, but
So the 4's will cancel.
And then you divide.
Then you're left with 3x equals 12, sorry. Getting distracted here. 8 plus 4 equals 12. Next step is to divide both sides by the variable coefficient.
By
sorry,
3.
when did I do this?
3 is the coefficient of x. 12 over 3 equals 4. So the gist, guys, sometimes I see a mistake where somebody tries to divide by 3 first. You've always add or subtract before you divide. Now, I know that's against PEMDAS, but a lot of times when you're solving an equation, you will do the reverse, okay? With PEMDAS, I know you divide first and then subtract or add, but when solving an equation, it's almost the opposite. Second example. Doesn't have to be exactly that form. So let's say we have 6, and then we'll do, let's do minus. 6 minus 7x equals 62.
Okay.
6 minus 7x equals 62. Okay. All right, so we're still going to follow the same method. We're going to add or subtract the constant on the variable side to both sides. What is the constant that we're going to be subtracting? 6. Nope, 7 is the coefficient. So the other number. So we're going to be subtracting 6 from both sides. Now the thing about this problem is you're still going to have a minus there, okay? It doesn't go away, so you're still going to have a negative in front of the 7. So you get negative 7x equals 62 minus 6, which is 56. And then we're going to divide both sides by the variable coefficient. What would you divide by in this case? Negative 7, good. So you included the negative because it's there. You can't do positive 7 is going to be negative because that is the coefficient.
Negative 8.
That cancels, and he is correct. 56 over negative 7 is equal to negative 8. And again, if we wanted to, we could take that number, plug it back in. We would get 6 minus a negative 7 times 8, which is 6 plus 56, which gives you 62. Next example. I'll go back in a minute. Okay, that's good. That is definitely the most important thing. Okay, let's do 69 equals 5a minus 1. Okay, so this time the variable is on the right side, but it doesn't matter, okay? It makes no difference at all. We still do the same steps. Let me draw the a, make it look a little bit better. So it says add or subtract the constant on the variable side to both sides. So what are we going to be doing? Somebody raise their hand and tell me. Adding 1 because it's the constant and it's on the variable side. So we add 1 to both sides. 69 plus 1 is 70.
And then
Whoa. Right?
no, 12 is 60.
So we're going to divide by 5. Okay, yeah. So 60 over 5 is 12. 70 over 5. Good job. You guys are quick.
No, not
And if we were to plug 14 back in, we would get 5 times 14 minus 1, which is 70 minus 1, which is 69. So it checks out. We'll do one more. Negative 39 equals negative 9 plus 6. Somebody give me a letter.
S.
S. Good. Just trying to do something different here. All right, so it says add or subtract the constant on the variable side of both sides. So in this case, you're going to do what? Add 9. Okay, that's fine. I made the same mistake all the time. Make the same mistake all the time. Negative 39 plus 9. Be careful. It's not negative 48. Negative 30.
Equals success, and then divide, which would be a negative.
Okay. Step 2, divide both sides by the variable coefficient, which is 6, and your right answer is negative 5s. Negative 5 equals s. And that's kind of why we don't use s, because it kind of looks like a 5. Let's just see if we can.
I mean, you could like make the 5 like.
Yeah, let's make the 5 a little bit better. There we go.
I don't understand how people could mistake with an S.
Well, when you have dyslexia.
If you write it to a certain degree, yeah.
I do not.
Let's do one more. I want to do a fraction.
5/4.
1/2 plus 5/3 v equals 3/4. Now this is actually still considered a two-step equation. Even though there's a bunch of fractions, they're still just numbers. Yes. What are you thinking about doing first?
What is the fraction that has the variable?
You actually subtract.
Okay, yeah, once we subtract, then we will flip. Yeah, multiply. Yes, 1/2 is the constant that is on the same side as this variable. So we need to, since it's a positive technically, right, we will be subtracting it from both sides. Okay, so that will cancel on the left side, and we'll be left with 5/3 v equals, good, yeah. We'll talk about how to get there, but for now we're just going to write 3/4 minus 1/2. Okay, so how did he get 1/4? Well, he took the fraction on the right and he made a common denominator. He multiplied it by 2/2, so he can end up with a 4 there. So it's 5/3 v equals 3/4 minus 2/4. It's crazy because there's a bunch of steps here, but like it's still technically a two-step equation. All right, so that equals 1/4 because we just subtract the tops. 3 minus 2 is 1. The bottom stays the same. Now what are you going to do? Okay, you can divide both sides by 5/3. Okay, and it will work, but what's the shorter way?
Convert each one by multiplying the denominators. So 5/3 times 4/4, and then 1/4 times 3/3.
Oh, you don't have to do that though.
Oh, really?
Yep. What's the quickest way? You mentioned it right before we did the problem. Multiplying by the reciprocal. Multiplying by the reciprocal of the variable. Okay? Whoops, that's not 3/4. That's 3/5. Okay? So when we spent a lesson on that. For some reason, I don't think you guys remembered it, but the reason we do that is because that cancels out and we're left with v on the left. Okay? And then when you multiply two fractions, you just multiply straight across. 3 times 1 is 3. 5 times 4 is 20. And there you go. So that's probably the hardest two-step equation you'd have to do in this particular form.